Hi guys, you're welcome to my channel. All right, today we are going to discuss about domestic installation load balancing, distribution board load balancing. All right. Before we comment on this, let's first of all analyze the use of this particular circuit arrangement. This portion is for those of us that are carrying out solar installations and inverter system in our domestic installations. So oftentimes we find out that technicians always come to distribution board and they alter the load balancing arrangement, existing load balancing arrangement on distribution board. They will alter the arrangement by taking away one of the supply and they replace it with lighting circuit. Okay, take note that distribution board is specially designed for power source of utility and the standby. And standby is for alternator. If alternator is not well, the load balance of alternator is not well arranged, the alternator coil, the winding will be affected. All right. So if an existing installation is done and the proper load balancing has been taken, so before coming to distribution board to alter the arrangement, you must devise the means of making the existing installation not to suffer from your alteration. Okay, if that is taken, another thing I will bring to your notice is that take a look at this particular load balancing. This is line 1, 60 amps, line 2, 52 amps, line 3, 45 amps. So this is the acceptable range of load balancing from generating set. If I have three-phase power supply and the load is not properly balanced, so alternator will be affected, will go bad easily. So and the lifespan of that particular equipment is at stake. So for us to maintain the load balancing of generating set, the output production of the coil, we must make sure that distribution board is evenly balanced. All right. Okay. Now, if you want to carry out distribution board load balancing by incorporating your solar system, I will make another video and show you the proper way of doing that particular load balancing. Instead of taking out load balancing from a cable from one particular line, because what we often find in the site or domestic dwellings is we will go to distribution board, we discover that lighting point will be assigned to a particular line, perhaps line 1. We assign lighting point to this line 1 and overload these other two lines by taking away load from here and share to these two lines and dedicate only one for lighting system. And that is a very wrong installation and a very bad exercise. All right, I'll do another video that will cover the arrangement of that distribution board if when you want to incorporate solar supply inverter system in a distribution board. Okay, but let us now analyze this particular one. Now, the lifespan and safety within electricity at home relies on the arrangement of your distribution board. If your distribution board is designed such that none of the outbreakers, or none of the star block outgoing breaker trip from time to time, they don't trip, but you discover that some socket and some of your appliances will be going bad and burning. Meanwhile, the excessive heat that make them to go bad supposed to respond to this particular distribution board. That means your design and your installation is failing. Okay, sorry, there's let me make a correction here. So let's quickly just hold on. Okay. Yeah, this one is coming out from here. All right, it's okay now. Now, let's quickly discuss about the installation. What does it entails? Installation arrangement entails the arrangement of this particular circuit requirement. Let's discuss about ring first. We have three standard socket arrangement. One is ring. You know the arrangement of ring that the cable must go through and flow. Now, the arrangement requires that is the stipulated law from IET, the Institute of Engineering and Technology, the regulatory body from UK that govern that particular installation, stipulate that 2.5 millimeter square, that is the cable size for ring circuit, is going to cover 100 meters only. You must make sure that your socket, the entire socket that is going to be on that circuit, is going to be confined within 100 meters only. Now that is the number one for the first standard. Second standard is radial. Radial is going to maintain 2.5 mm square, and the distance covered within the cable route will be maintained within 50 meters. Then another one is another radial 2, 4 mm square. The distance covered of the cable is going to be 75 mm square only. All right, sorry, 75 meters and 50 meters and 100 meters. So these are their cable sizes. Then oftentimes we discover that we do radial circuit without ring circuit, and we protect it with 32 amps, which is wrong. And the number of sockets within the circuit will be very few, very limited, about 5 circuit only, first 5 points, sorry, 5 socket outlet or 6 socket outlet. Some of them are 7 socket outlet, but the protective device from distribution board will be 32 amps. And they take note, all the cables, all your outgoing circuit must attain a particular heat level before breaker respond to fault. So if your cable size is high and your MCB is also high, it's not the selectivity and the segregation and load segregation is not properly done, your outgoing breaker will not respond. What am I saying in essence? If you have, for instance, I have 5 mm square, and use I now go and use a 15 amps to protect this particular cable size, the fault will not respond because this cable is very high. Before the temperature of 4 mm will respond to 15 amps, it will take a long time. So that is why you must make your load segregation very considerable. All right. So we must know how to use this. Then come to air conditioner. Air conditioner of 1.5 horsepower shouldn't be protected with 32 amps. All right. If you convert 1.5 horsepower to kilowatt and divide it by the voltage, including the efficiency, you will have less than 15 amps to protect that air condition, even the starting current added. So you shouldn't use higher breaker size to protect your air condition. So air condition, I have two here. One is 2.5 mm square, and that is 15 amps. Then one here is 4 mm square, and that is 20 amps. So this one could be 2 horsepower, and this one could be 1.5 horsepower or 1 horsepower, right? Okay, so this is the arrangement of your installation from the beginning, from your installation. Then the load balance is what you are going to make sure you maintain this other format in order to maintain uh, the proper stipulated law of distribution board. All right. Then there's what we also have here. We have a diversity factor. Diversity factor tells us about load that are not engaged in service at the same time. For instance, some of your lighting circuit will be diversified. Those of them that are not on at a particular time will be diversified. If I have 10 point, 10 point of light in a circuit, so 10 of them simultaneously cannot be put on at the same time. About 5 or 6 will be diversified, then the rest will be on. So because of that, we apply diversity, okay, with this percentage. So I will do another video that I will also stipulate, I will also describe how to get this diversity factor. I'll also bring the table of diversity. I think I have a picture of standard ring circuit, something like this. So take note, if you want to do the local way of a standard circuit, you can meet up and do your ring circuit. I want to do local way of a ring circuit, that is a radial circuit. So take note, each point of your ring point is entitled of 3 amps. So if you want to do it that way, maybe you want to use a 5 point to make one ring, one radial, or 6 point to make one radial. So the formula for you is 3 amps. So you say 3 times the number of sockets you want to electrify. So multiply them, and from there you now get your outgoing breaker to protect from the distribution board. For instance, I want to do a radial circuit and I want to use